Okay, this is the second part of the 3.5 notes for Algebra 1. So this is a real-life problem. It says you are planning an awards banquet and need to rent tables that seat 180 people. There are two table sizes available, small tables that seat 6 and large tables that seat 10. It wants us to write an equation that models this situation where it says that x is the number of small tables and y is the number of large tables. So small tables seat 6, so that's 6 times how many small tables you get, so 6x. And large tables seat 10, so that's 10 times how many large tables you get, so 10y. And you need it to seat or equal 180 people. So 6x plus 10y equals 180 is our equation. Okay, it wants us to graph the equation, so let's use the x-intercept. Okay, so the x-intercept is where you plug in 0 for y, so you have 6x plus 10 times 0 equals 180. All right, the 10 times 0 is just 0, so it's 6x equals 180. You divide by 6, and you get x equals 30. So if we go ahead and interpret this, it says interpret the intercepts, which means tell what it is in the actual problem, like using things from the problem. So if you rent, remember y was large tables, so 0 large tables will need, or you will rent 30 small tables. That's what that means. So if you have 0 large tables, you're going to have 30 small tables. Let's go ahead and find the y-intercept also, which remember is where we plug in 0 for x and we solve for y. So we get 10y equals 180 because 6 times 0 is just 0. Divide by 10 and you get y equals 18. So what that means is if you don't rent any small tables, so if you rent 0 small tables, then you're going to need 18 large tables. All right, so try to squeeze that in there. The x-axis down here, remember x is the number of small tables. Now, we need to go all the way over to 30, so I'm feeling like probably 2s would be a good idea. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. And then the y-axis, we need to be as high as 18 is our y-intercept. So I think going by 2s there also makes sense. So 2, 4, 6, 8, 10, 12, 14, 16, 18. The top is 20. Okay, so if you put it on here, you're at 18 there and you're at 30 here. This is a spot where it would be very important to use a straight line, like some type of using either a ruler or a straight edge. In my case, I am going to just go ahead and use the line feature and draw it on here. Okay. All right, I think that's pretty close. Okay. So, all right, it says find 3 possible solutions. Well, some of these solutions wouldn't really make sense because you wouldn't rent, half of a table. So 3 different combinations are, you could have your y-intercept, which is 0, 18. That's 0 small tables and 18 large. You could also have like your x-intercept, which is 30, 0. That's 30 small tables and 0 large. And then any other point on this line that looks like it's going through, an exact point. So for example, right here, this is the point 10, 12. That would be 10 small tables and 12 large. Okay, you could also have done like this one at 24. which is 20 small and 4 large. Those are just some different examples that you could have used. Okay, let's try another one like this. You're planning a birthday party. You have $160 to spend in total. The roses are $40. The bouquet of tulips are $20. So X is the number of rose bouquets. So roses were 40, so it's 40X. Y is the number of tulip bouquets. Tulips were 20, so it's 20Y. And combined, so adding together, you want to spend $160. So first find your x-intercept. That's where you plug in 0 for y. Right, you get 40x equals 160. If you divide by 40, then you get x equals 4. So what that means is if you buy 0 tulip bouquets, you buy 4 rose bouquets. Let's find your y-intercept. Your y-intercept is where you plug in 0 for x. So it leaves you with 20y equals 160. I ran out of room, but we're going to divide by 20, and we get 8. And what that means is if you buy 0, remember x was roses, then you're going to buy, let's see, it was 8. You will buy 8 tulip bouquets. Okay, so let's see if we can graph this. So remember the x-intercept was 4. So we don't need quite as big of a graph as I gave us here. So I'm just going to go by ones right here. 1, 2, 3, 4. And remember, this is the number of rose bouquets. And it's going to have an x-intercept at 4. And then the tulip bouquets, this is the number of tulip bouquets. Was 8, 2, 3, 4, 5, 6, 7, 8. Sorry, get the little crooked there. Okay. And on these, use a straight edge or a ruler or something to make it come out straight, because when you actually go to find your other solutions, it's just going to cause a problem if you don't have a straight line. All right. So it says find 3 possible solutions. Well, I could use 4, 0. I could use 0, 8. And let's see here. I could do like this one at 3, 4. Or, I'm sorry, that's 3, 2. Or I could do this one at 2, 4. Or I could do this one, which was at 1, 6. Any of those would be fine. I'm going to use the one at 1, 6. And the X value is, meaning you bought 4 rose bouquets and 0 tulip bouquets. G. And then this means 0 rose bouquets and 8 tulip bouquets. And then 1 rose bouquet and 6 tulip bouquets. Those would be in the context of the problem.